Hello dear students, I am Chetan Singadia from Dr. Subhash Technical Campus. You are watching the video lecture for the subject of Database Management System. In this video lecture, we are going to discuss domain and data dependency in DBMS. So let us start with domain and data dependency. Dear students, in this video lecture, we will learn the definition of domain and functional dependency. Also, we would like to see the key terms that are very much important to understand the domain and functional dependency. We will see the inference rules. There are different inference rules are there in data dependency, or we can say Armstrong axioms. We would like to see the rules of functional dependency. So let us define what is domain in DBMS. A table is a DBMS is a set of rows. A table in a DBMS is a set of rows and columns that contains data. Where column in a table have a unique name and which is often referred as attributes in DBMS. So this is very much simple definition of domain. Let me explain what is that. In a DBMS, what is table? Table contains set of rows and columns that contains the data. And each column in a table have a unique name. It's often referred as attributes in a DBMS or attributes in a table of DBMS. A domain is a unique set of values which is permitted for an attribute in a table. What is domain? A domain is a unique set of values which is permitted for an attribute in a table. So we have to make sure that whenever we are talking about the domain, it should represent the valid set of unique values. For example, a domain of month of year can accept January, February and so on till December as possible values. So according to the domain of integer can accept whole numbers that are negative, positive and 0. So this is what the simple understanding of domain. Now let us understand what is functional dependency in DBMS. That we can call it as a FD also. And some of the times in the reference book or a textbook, there may be written functional dependency or there may be written like simple FD. So functional dependency determines the relation of one attribute to other attributes to a DBMS system. What is functional dependency? The functional dependency determines the relation of one attribute to another attribute in a DBMS system. So ultimately the use of functional dependency is to define relation between one to another attribute from a table. Functional dependency also helps you to maintain the quality of data in the database. And the functional dependency is denoted by an arrow. This is denoted by an arrow. Like how we can define? Let us see that. The functional dependency of X on Y is represented by X is dependent on Y. This is how we can represent functional dependency in DBMS. How we can define? If there is a functional dependency X on Y, and that can be represented by X is dependent on Y. So this is how we can define the functional dependency in DBMS. Also, the functional dependency plays a vital role to find the difference between good and bad database design. So one of the most important aspects of functional dependency play a very much important role to find the difference between good database design and bad database design. So this is what similar understanding functional dependency, how we represent it, how it should be in detail. The another important term is dependent. Dependent. What is the dependent? It is displayed on the right side of the functional dependency and the dependency diagram. That means when we are saying that dependent, if I am saying that X tends to Y, then Y can be called as a dependent. And what is determinant? It is displayed on the left side of the functional dependency diagram. Similarly, that example that I said to you, when we are saying that X tends to Y, in that Y is called as a dependent and X is called as a determinant. So this is how this dependent. Now let us discuss some of the rules of functional dependency. The below are the three most important rules for functional dependency. One is a reflexive rule, and another one is the augmentation rule, and third one is the transitive rule. These are the three basic rules for functional dependency. Let us define reflexive rule. If X is a set of attributes and Y is a subset of X. Let me explain once again what is reflexive. If X is a set of attributes and Y is a subset of X, then X hold value of Y. Then we can say it is reflexive. What is augmentation rule? When X tends to Y holds and C is attribute set, then we can say that AC tends to BC is also hold. So this adding attributes which do not change the basic dependency. This is called an augmentation rule. Then we would like to see the transitivity rule. The rule is very much similar to the transitive rule in algebra. If X tends to Y holds, then Y tends to Z holds, then we can say that X tends to Z holds, and X tends to Y is called functionally that determines Y. So these are the simple rules of reflexive augmentation rule and transitive rule, that we can call it as the rules of functional dependency. That is reflexive rule, augmentation rule, and transitive rule. We will see this all these three rules with the example in our video also with the example. Now let us talk about what is inference rule, or we can say IR in functional dependency. The Armstrong axioms, we can say Armstrong axioms are the basic inference rules. These Armstrong axioms are used to conclude the functional dependency on a relational database. The inference rule is a type of assertion. It can apply to set of functional dependency to derive the other FDs. Using the inference rule, we can derive the additional functional dependency from the initial set. Now, so in this inference rule, what is the main important thing that these are the, first of all, we have to understand these inference rules are the basic inference rules. And to conclude the functional dependency, or to get some important information from the functional dependency, we should use these inference rules. It is a type of assertion. Now, when we want to apply to set of functional dependency, so when we are using, if we want to derive some functional dependency based on some other functional dependency, in that case we are using this inference rules. So, using this inference rule, we can derive the additional functional dependency from the initial set. So, this is what the basic importance of inference rules. The functional dependency has 6 types of inference rules. Let us understand that particular 6 rules with an example. Now let us talk about the reflexive rule 1, that is IR1. In the reflexive rule, if Y is a subset of X, Y is a subset of X, then X determines Y. Now, how we can write this reflexive rule in the functional dependency? So we can say, if X is a proper subset of Y, if Y is a proper subset of Y, then X tends to Y is called as a reflexive rule. Let us understand how it can be, and this proper subset is denoted by this way. So there are many more terms are related: subset, proper subset, and this also. So that you have to keep in mind. Now here you can see in this example, X is equals to, there are 5 elements A, B, C, D, E, and Y is equals to A, B, C. So what we said that in the, now let us understand what is union rule for a functional dependency. That is rule number 4, or we can say IR4. A union rule says that if X determines Y and X determines Z, let me repeat once again, if X determines Y, once again X determines Z, then X must also determine Y and Z. This is simple. So when we say that X is determined Y and X is also determined Z, so we can say that X must be determined, X must also determine Y and Z. So how we can write down? If X determines Y and X determines Z, then we can say that X determines Y and Z. So this is what an union rule of functional dependency. Let us understand this with an example. So the proof of that union rule is when X tends to Y and X tends to Z is given. So how we can write down? We can write down X tends to XY by using IR2 and by one augmenting with XX is equals to X and XY is equals to YR. For that we are using IR2 and 2 by augmenting with Y, and then we can say that X tends to YZ. So this is how the proof of that union rule is also available. So this is, with the help of this proof, we can write down if X tends to Y and X tends to Z, then we can say that X tends to YZ. That is the union rule for the functional dependency we can write down. So this is what a simple understanding of union rule in functional dependency. Now let us understand what is a decomposition rule in functional dependency. That is the rule number 5. A decomposition rule is also known as project rule. It is the reverse of union rule, and this rule says that if X determines Y and Z, then X determines Y and X determines Z. So ultimately, according to the decomposition, we are going to decompose the rule. So let us understand how we can define that particular rule. If X tends to YZ, that means if X determines. Now let us understand the most important topic, that is functional dependency. The functional dependency is a relationship that exists between two attributes. The functional dependency is a relationship that exists between two attributes. It typically exists between the primary key and non-key attributes within a table, or we can say it is exists between key attributes and non-key attribute within a table, and that can be denoted by X tends to Y. The left side of FD is known as determinant, that means X can be known as a determinant, and right side of the production is known as dependent, and right side is, that means Y is known as dependent. Assume that we have an employee table with attributes employee ID, employee name, employee address. Here employee ID attributes can employee ID attributes can uniquely identify employee name attribute of employee table, because if we know the employee ID, we can tell that employee name associated with it. So the functional dependency can be written as employee name is dependent on employee ID. So why we have written like this way? So we in this we have the proof of that employee ID attribute can uniquely identify the employee name. That means when we want to derive the employee name, we will use the employee ID. So we can say that employee name is dependent on employee ID, and that particular functional dependency can be written like this way. We can say that employee name is functionally dependent on employee ID. What we can say, employee name is functionally dependent on employee ID. So this is what in simple understanding of functional dependency in a relational algebra in DBMS. Now, after understanding the functional dependency, we have to understand the trivial functional dependency and non-trivial functional dependency in a functional dependency. They may be in an examination, they may be asked about explain what is functional dependency and explain the types of functional dependency with a proper example. So the two types of functional dependencies are there, trivial and non-trivial. Let us see each one by one with an example. The trivial functional dependency. Let us understand trivial functional dependency first. A determines B, which has trivial functional dependency, or we can say B is functionally dependent on A, has trivial functional dependency if B is a subset of A. B is a subset of A. That means whatever the element of A has, that element, at least that element should available in B. So we can say B is a subset of A. If B is a subset of A, then we can say that particular dependency is trivial functional dependency. The following dependency are also trivial, like A is determine A and B determines B. Example, let us understand with an example. Consider a table with two column, employee ID, employee name. Now, in the bracket you can see employee ID and employee name determines employee ID is a trivial functional dependency, where employee ID is a subset of employee ID employee ID and employee name. So what we have described here you can see this is a one entity. This is a one entity which covers two attribute, employee ID and employee name. With the help of this entire attribute, composite attribute, we can determine employee ID. So we can say that this employee ID, or we can say this B is a subset of A. Let us understand, this will call it as A, this line is call it as A, and this will call it as a B. So B is a subset of A. B is a subset of A. According to the definition, B is a subset of A. Then we can say that it is a trivial functional dependency. And here is in this example also we have said that employee ID is on the right hand side and it is also available on left hand side. So we can say that it is a, or we can say it is a proper subset of each other. So we can say it is a trivial functional dependency. So this is how we can define the trivial functional dependency. Now let us understand what is non-trivial functional dependency. Now A determines B has non-trivial functional dependency when if B is not a subset of A, and now it is opposite to the trivial functional dependency. In trivial functional dependency we said that B is a subset of A. He not of me of in B Now let us understand what is multi-value dependency. The multi-value dependency occurs in a situation where there are multiple independent, multiple attributes in a single table. Let me explain once again what is multi-value dependency. The multi-value dependency occurs in a situation where there are